Hi, this is Chandran. I have done bachelor's in aeronautical engineering. Today I am going to present a small topic which is X-noise. X-noise is nothing but a currently ongoing project to reduce the aircraft noise as well as the aero acoustics. And it's a collaborative network project in the area of noise reduction as well as the reducing the noise in the aerospace aircraft engines as well as the landing gear sounds as well as the noise source which is produced by the aileron sound as well as the airframe sounds and the flaps, slats. These are the sounds which is comes under the X-noise section. And the main aim of the project is to reduce the noise up to 6 decibel over the next 8 years, and it has to reduce the up to 50% of noise in the ground area as well as the aircraft operations. And it's a second phase of the fan pack project which is involved in the which is 32 organizations involved in these fan pack projects. And these organizations are mainly production the aerospace engines as well as the aerospace systems. And next we are going to see about what are the categories which is involved in the X-noise sections, which is resound and rantac and rain and ducat. Resound in the sense it is the noise produced internally in the engine by means of the propeller as well as the compressor blades and low pressure turbine and high pressure turbine. And these are the sounds which is comes under the resound. And next one is rantac. Rantac is nothing but the engine cooling. Engine cooling in the sense it's a natural structure of the aircraft engines. And these are the sounds comes under the thrust reverser as well as the inlet cowl, outlet cowl of the aerospace engines. The next one is rain. Rain in the sense comes under the airframe of the aircraft. It's mainly formed due to the turbulent flow. Turbulent flow interact with the solid bodies. And next one is ducat. Ducat in the sense it's a sound produced by the engine fan as well as the turbines which is involved in within the engine of the aircraft. And these are the main sounds produced by the aircraft. And it has to be divided into 4 categories like resound, rantac and rain and ducat. Next, what are the noise sources which is involved in the aircraft is engines and slats, flaps and landing gear. Engines and landing gears are produce maximum sound which is involved in the aircraft. And next one is airframe. So it's mainly formed due to the turbulent flow interact with the solid bodies. And the pilot and the slats, flaps are the control surface. These are some sounds produced during the operations. And next one is alien sound. Alien sounds in the sense it's produced by the wing. It's interact with the aircraft structures as well as the landing gears and as well as the engine interacts. The next one is noise sources. Noise sources on the engine is based into 2 categories. One is first generation engine. Next one is second generation engine. In the first generation, in the sense it's like Boeing 707 engine. Generally, this type of engines have producing more sound compared to the second generation engine. It's having a low pressure turbine as well as the number of airfoils fans are increased in this first generation engine. In this second generation engine, it's a very compact engine. It's have less type of fans as well as the it's a very efficient turbine rotation as well as the very smooth flow inside the engine. So this type of engine producing a small noise as well as it's increasing the efficiency of the engine. Generally, these types of engines used in the Airbus as well as the Airbus 330, 380 as well as the Boeing aircraft. And next one is the noise production rates in the aircraft is divided according to the speed of sound as well as the Mach number of the aircraft. It has to be divided into four categories. One is subsonic and sonic, supersonic and hypersonic. So subsonic in the sense it's a Mach number is less than 1. That is the speed of aircraft to the speed of sound is less than 1 between the range. And next one is sonic is the Mach number is equal to 1, and the supersonic in the sense the Mach number is between 1.224. And the hypersonic in the sense the Mach number is it's a very high speed of sound engines. Its Mach number is between the 8 to 10 and 10 to 11 range is between these things. And based on the engine product speed of sound is based on the engine as well as the engine production sound, and this has to be categorized in four types. And next one is what are the tools used to reducing the noise in the aircraft is one is boundary element method. Generally boundary element methods are used to reducing the noise and the vibrations as well as air acoustics in the aircraft engine. And another one method is computational air acoustics. And computational air acoustics is generally used to solve air acoustics problems by using numerical methods and computer aided problems. Another one is CFD methods. Generally it's rare to use to solve the problems. Generally it is used to solve the problems arising from the landing gear as well as the aerodynamics flow, which is involved in the airframe structures and the engine structures. Generally it's computational fluid dynamics are used. Finally, what are the nations and organizations which is involved in the X-Nice project is there are generally Stigma and Turbomax that is comes under the Safran, and Rolls-Royce, Dassault System, B&W. These are some organizations which is involved in the X-Nice projects. And General Electric Aviation plays important roles to reduce the aerospace noise as well as the aircraft systems. And it plays an important role to produce the manufacturing engines like GE19 engine. It's a high bypass ratio engine, so it's produce a low noise as well as the high efficiency engine. And next one is CFM 56 and 5C2 engine. It's having a long dead at the exit as well as the mixed flow nozzle. So in the CFM 56 engine is produce a low noise. And next one is CF3483 engine. It's having a high pressure turbine as well as the low smooth engine. So it has the exhaust of the engine producing low noise as well as the rotation of the compressor blade as well as the turbine blade. And final one is CFM 56 engine. CFM 56 engine is made by the advanced design technologies as well as the using the sound absorbing material. So it's producing low noise. These are the basics of engines which is produced by the GE Aviation. And finally, what are the advanced projects which is going on in the GE Aviation is advanced compressor designing. It's reducing the number of airfoils, that is reducing the number of compressor blades as well as the reducing the number of turbine blades. These are the main research going on the GE Aviation. And one more, finally it's using sound absorbing material as well as the advanced designing technology. These are the main advanced programming which is going on the General Electric Aviation technology. Finally, what I conclude that reducing the aircraft noise as well as the engine noise. Generally, aircraft engine manufacturing companies are playing important role in these X-Nice projects. And GE Aviation plays important roles in reducing the engine noise and as well as the using sound absorbing material and latest design technology and advanced designing methods are used to reducing the X-Nice technology. Thank you.